A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi, welcome to the wonderful world of physics. We were discussing the magnetic needle and the compass. Here we can see a magnetic needle. The needle is having a north pole and a south pole. We've already learned that the magnetic needle is having a magnetic field around it, and the direction of magnetic field lines are from the north pole to the south pole. This is the same case with respect to all the magnets. The magnetic needle here is pivoted on a needle. Now bring another magnet closer to the magnetic needle. This magnet is also having a magnetic field. Here, when the magnet is brought closer to the magnetic needle, there are two magnetic fields at the same time and at the same place. That is, when we bring a magnetic needle that moves freely in a magnetic field, due to mutual action of the magnetic field, the needle would deflect. Here, when two magnetic fields comes into contact with each other, there is a mutual action. The magnetic needle that can move freely in the group gets deflected. Here we can see a straight wire held parallel to the magnetic needle. The wire is connected to a battery and a switch. When the switch is turned on, the magnetic needle instantly deflects. When the switch is turned off, it returns to its original position. The magnetic needle has its own magnetic field. Now, when the switch is turned on, current flows through the wire. This develops a magnetic field around the wire. Here, we have two magnetic fields at the same time and at the same place. As a result of the mutual action between the two magnetic fields, the needle deflects. This is a reason for the deflection of magnetic needle. So, in which direction did the magnetic needle deflect? There is an easy way to find out or remember it. Imagine that a person is swimming in the direction of electric current in a conductor facing the magnetic needle. The north pole of the magnetic needle deflects towards the left hand. This is Ampere's swimming rule. We know that the current flows from the positive terminal to the negative terminal. So here, the direction of electric current is from A to B. The freely moving magnetic needle is placed below the wire AB and is kept parallel to the wire. Let's roughly mark the directions as north, south, east, west, based on the principle that the direction of freely moving magnet is in the north-south direction. Now, let's move into the concept. Here, the current flows from A to B. At present, we are asked to find out in which direction would the magnetic needle deflect when the switch is turned on. Consider a person is swimming in the direction of electric current, that is, from A to B, towards the north pole. The deflection of magnetic needle with respect to north pole will be in the direction of his left hand, which means the pole of magnetic needles moves in the west direction. Here, if we complete the arrow marks, it becomes clear that the magnetic needle is moving in the anti-clockwise direction, that is, in the opposite direction of the movement of hand in a clock. So, the magnetic needle deflects in the anti-clockwise direction. Now, let's change the direction of electric current. That is, the current flows from B to A. See, the magnetic needle deflects. How to change the direction of electric current? We need to reverse the battery. Here, when the switch is turned on, the magnetic needle deflects in the east direction. Are you confused? Let me tell you how to remember it. The north pole of the magnetic needle deflects in the direction of the left hand of a person swimming with the magnetic needle pointing from B to A. That is, if you look at their arrow marks, here it is towards the east direction. You will see that the magnetic needle deflects clockwise. Now let's see how the magnetic needle moves by placing the magnetic needle above the wire as the current flows from A to B. Here the current flows from A to B. Because the magnetic needle is placed above the wire, the person swimming from A to B will swim facing upwards. Then the north pole of the needle deflects in the direction of the person's left hand when the switch is turned on. Here, the north pole of the magnetic needle moves in the east direction when the switch is turned on. That is, in the clockwise direction. Now, if we change the direction of electric current, when the current flows from B to A, the person swims from B to A. The magnetic needle moves in the direction of the person's left hand, that is, in the west direction, which means the arrow mark shows it is anti-clockwise or counterclockwise direction. When the battery is connected in the opposite direction and the current is reversed, the needle deflects in the opposite direction. This is due to the inverse of the magnetic field around the conductor. Also, in all the cases, when the switch is off, the magnetic effect of the magnetic needle disappears. Now, let's complete the table in the palm book based on this observation. The direction of electric current from A to B when the conductor is above the magnetic needle. The direction of motion of north pole of the magnetic needle will be anti-clockwise or counterclockwise. And in case if the current is reversed or in the opposite direction, that is from B to A, direction of motion of north pole of the magnetic needle will be clockwise. If the conductor is below the magnetic needle and the current is from A to B, then the direction of motion of magnetic needle at the north pole is clockwise. If it is from B to A, then the direction of motion of north pole of the magnetic needle is in the clockwise direction. These experiments that we have seen was carried out by a scientist named Hans Christian Ørsted. In 1820, Ørsted was doing an experiment with electricity in his laboratory. Accidentally, he noticed that the magnetic compass placed on his desk was deflecting. He thought there was no magnet nearby, yet what caused the magnetic needle to deflect? Finally, he discovered that when current passes through a conductor, a magnetic field is developed around it. And this magnetic field made the compass to deflect. The direction of deflection depends upon the direction of current. Thus, the unbreakable relation between electricity and magnetism was realized for the first time. His experiment marked the beginning of technologies behind the devices used today, like radio, television, etc. As a mark of respect, the CGS unit of intensity of magnetic field has been named as Ørsted. So, we have understood that a magnetic field is formed around a current carrying conductor. Now, let's find out the direction of magnetic field through an experiment. Here, the conductor is inserted through a cardboard. Here, the conductor is inserted through a cardboard and kept in a vertical position. It's connected to a switch, battery and rheostat. The portion passing through the cardboard are marked as X and Y. Now the switch is turned on and the current passes through the conductor. Keep a compass near the point X or the conductor AB. Notice the direction of deflection and mark the north pole. Keep on changing the position of the compass away from the point X and draw 3 to 4 magnetic lines. Now let us follow the same steps with the conductor CD or the point Y. Here also we have obtained the magnetic field lines. We can see that around the point X, magnetic field lines are in the anti-clockwise direction or counterclockwise. Similarly, the magnetic field lines around the point Y are in the clockwise direction. There is an easy way to know the direction of magnetic field around a conductor. Here, the current flows from A to B. Assume that you are holding a current carrying conductor in your right hand. The thumb indicates the direction of flow of current and the remaining fingers encircling the conductor would give you the direction of magnetic field. This is called Maxwell's right hand thumb rule. This same rule is also known as Maxwell's right hand screw rule. When the right hand screw is tightened, the tip advances in the direction of the electric current, and the direction of rotation of the screw indicates the direction of magnetic field. We may often have doubt about where to turn the screw to loosen a good tight one. With this principle, we can easily overcome the problem. We will soon understand much more about magnets.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ Enclaps, the learning app.